Hello, my name is Christian Williams. This is my Circ08 A Attempt. The date is November 12th of 2021. This A Attempt is extremely similar to our CIRC04 B attempt. This one is supposed to be focusing more on the potentiometer, but this specific project, as we can see recorded, confirmed by my professor here, that the servo potentiometer used in CIRC04 is also required for the CIRC08. And we can also see in our project over here that we are going to making it better and controlling a servo, that we are going to be using pretty much the exact same code that we already constructed in the CIRC04 B attempt. So I won't go over detail of that code and specifics in regards to how to operate the servo, since I've already covered that. I will merely focus on the code that is new to this project. In this case, I have added 6 LEDs programmed to respond to the servo's position as the unique component added to CIRC04 B to make it appropriate for the Circ08 A attempt. So after including the servo library and setting up our servo, these are what is new to this program. We are adding 6 constant integers, specifically LED pins 1 through 6, set to pins 13 through 8. We have changed this integer to be a constant integer, as this is the pin that our potentiometer is programmed into. And we have set our 6 LEDs to output. That is all new prior to the loop. Void loop, this is all stuff that was already inputted here. The important thing is that we are constraining the potentiometer from 0 to 180, since the servo is 180 degrees. This is the new code, so this is what I'm focusing on the details of. So we have 6 LEDs. We are using a decision statement and a logical argument to figure out when the Arduino will turn on each LED. So we've already used this if-else statement. I've kind of covered that in the past. So if, in the parentheses here, we basically have our test or conditional statement to see if will run or whether it defaults or skips to else. So in this case, I'm using a logical operation with these two and signs here. This is the logical capital and. So if this statement is true, both of these have to be true in order for this function to be true. How we symbolize OR is with 2 lines that basically looks at the pause sign on like an iPod or something like that. So in this case, if the potentiometer's value is greater than or equal to 0, and it is less than or equal to 30, this becomes true. And therefore, it will write the LED pin 6 to high, basically turning it on. If either of these conditions are found to be false, so for example, if the value is set to 31, it would be true for this side, but it would not be true for this side, because 31 is not less than or equal to 30. Therefore, LED pin 6 would remain off. That is basically how that is logically being constructed in this statement. So we can see down here for the second LED, if the value is greater than 30 and the value is less than or equal to 60, the 5th LED will be turned on. Otherwise, it will remain off. So basically, I've set a range that every 30 degrees is associated to a specific LED. Since it's 180 and I have 6 LEDs, it just happens to mathematically work out to 30. So you can see that we have our 60 and 90, 90, 120, 120, 150, 150, 180. That is the new code that has been uploaded into the board for our Circ08 A attempt. How that looks like in real life is this device right here. So you can see it's already plugged in. I've already compiled it, and you can see the red LEDs are currently on. As I discussed in the CIRC04 B video, this potentiometer is already set to a 1-to-1 relationship with that servo over there, or is close to 1-to-1. This potentiometer actually goes beyond 180 degrees when you twist it, but it basically gets our same purpose here. Wiring-wise, you can see the 6 LEDs in a row here, along with these bridges, just to get a kind of little bit of symmetry and to maximize our entire board. They are plugged into their respective pins over here and each have a resistor to make sure the LEDs don't burn out. Our servo is connected up in this quadrant here with our negative power and with our sensor cable plugged into pin 3. And our potentiometer, since it is an analog input, is set to our analog 3 pin over here. So analog 3 controls pin 3, just for consistency's sake. And then, of course, we're bridging power into that second column so the servo has some. So, to demonstrate this in action, when I turn the potentiometer, you can see the servo, as it moves through each 30-degree range, turns on a different LED. Moving backwards. Servo isn't instantaneous, so you could, for example, go from 0 to 180. You can see the servo tries to catch up. But thankfully, we can get it to wiggle and it'll do its best based off of the programming there. So, that is my Circ08 A attempt. If you're interested in figuring out how the rest of this program works, I invite you to look up my CIRC04 B attempt as I explain more about how the servo works with this program. Otherwise, I hope you enjoyed watching that, and have a nice day.